ISRO achieves major breakthrough in semicryogenic engine for launch vehicle. ISRO has announced a significant progress in the design and development of a semicryogenic engine or a liquid oxygen or kerosene engine with a high thrust of a 2000 kilonewton that will power the semicryogenic booster stage of the launch vehicle Mark III. The first major breakthrough in the semi-cryogenic engine development program was achieved on March 28 when the first successful hot test of an engine power head test article was carried out at ISRO Propulsion Complex, Mahendragiri, Tamil Nadu, it said, highlighting that the Friday's test demonstrated the smooth ignition and boost strap mode operation of the engine for a test duration of 2.5 seconds. The space agency said the objective of the test was to validate the integrated performance of the critical subsystems such as the pre-burner, turbo pumps, start system and control components by carrying out hot firing for a short duration of 2.5 seconds. The test proceeded as predicted and all the engine parameters were as expected. With this breakthrough, ISRO is further planning a series of tests on the PHTA to further validate the fine-tune the performance before the realization of the fully integrated engine, it said. Noting that the Liquid Propulsion System Center of ISRO is developing the semi-cryogenic propulsion engine and stage. ISRO said the stage powered by the 2000 kN semi-cryogenic engine will replace the present core liquid stage of LVM3 for payload enhancement and power the booster stages of future launch vehicles. Non-toxic and non-hazardous propellants, liquid oxygen and kerosene, are employed in semi-cryogenic propulsion and this will deliver higher performance compared to existing L110 stage. Induction of the semi-cryogenic propulsion system along with an upgraded cryogenic stage in the LVM3 vehicle enhances its payload capability from 4 ton to 5 ton in a geosynchronous transfer orbit, it added. According to ISRO, major subsystems of the SC2000 engine include thrust chamber, pre-burner, turbo pump system, control components and a startup system. The complex engine hardware uses special materials to withstand the high temperature and oxidizer-rich combustion. The hardware along with the space-grade kerosene and realized in a partnership with the Indian industry. The development of this engine in these high thrust levels is highly challenging and this technology is available with only very few nations. The realization of a test facility to qualify the engine and stage is equally complex and challenging, ISRO said. The complex semi-cryogenic integrated engine test facility was established at its propulsion research complex Mahendragiri for testing the engine and stage and was dedicated to the nation by Prime Minister Narendra Modi on February 27 last year. Prior to the conduct of integrated engine level hot tests, it is planned to carry out a performance evaluation tests of the intermediate configuration designated as powerhead test article which comprises all the engine systems except the thrust chamber, it said. The hot test that was carried out on Friday is the first of a series of tests planned to validate the design of the propellant feed system, including the low pressure and high pressure turbo pumps, the pre-burner start system and control components. All subsystems for the test were realized and had undergone rigorous qualification tests prior to integration to powerhead test article, the space agency said. The ignition sequence for a PHTA was derived from a series of hot tests in a single element level, ISRO said. In order to ensure the smooth ignition process during the PHTA test, another test article, pre-burner ignition test article, was realized, which consists of the pre-burner along with its feed systems, start systems and related control components. A series of tests were successfully completed using the PITA and the optimum start sequence for the power head test article was derived, it said. Thank you for listening. Thank you for watching. Thank you everyone. Bye.